Sadly, there are some students out there that struggle so much when it comes to naming organic compounds. For example, a compound will be given to them and they'll be asked to name the compound. Some of them struggle a lot. If you're one of those students, then the good news is if you pay close attention to this lesson, you'll find it easy to name compounds. So let's get started. You can see some stuffs on the screen. These are known as polyatomic ions, meaning poly means many atoms. So these polyatomic ions have two or more atoms combined to form their ions. And your responsibility is to know the symbols and their names, and then you are good to go. So OH minus is hydroxide, NO3 minus is nitrate, SO4 2 minus is sulfate, CO3 2 minus is carbonate, NH4 plus is ammonium, then HCO3 is what? Hydrogen carbonate. So your responsibility is just look at these symbols of these polyatomic ions and then master them, and then you are good to go. Yeah, basically that's all you need to know. Good. Another concept I want you to know is variable oxidation state. Variable oxidation state. Well, before we look at variable oxidation state, I want to introduce you to something. You see, sometimes you see something like Na plus, maybe O2 minus. Good. The charge you see on top of this atom, most of the time, is known as their oxidation state. So this means this sodium atom has an oxidation state of +1. Most of the time, the charge on them is the oxidation state. And we have oxygen to have an oxidation state of -1 and -2. Sodium will always have oxidation state of +1. Meanwhile, we have some other atoms like iron can have oxidation state of +2 or oxidation state of +3. This is simply because they form part of the transition metals. Don't worry yourself too much understanding why that is the case. All I want you to know is that iron can be Fe2 plus or Fe3 plus. Then we also have this copper, Cu plus or Cu2 plus. So copper can be Cu plus or Cu2 plus, depending on the atom it is bonding with. So keep this in mind. These two compounds, or these two atoms, are referred to as atoms having variable oxidation state. Variable means their oxidation state can change depending on the compound we are considering. So for BC level, these are the two common atoms that have variable oxidation state. There are more out there, but the one that normally comes in your final exam are iron and copper. So if you meet iron and copper, what you should keep in mind is you have to state the oxidation state, whether it is iron 2 or iron 3. And then if you meet copper, you have to state whether the copper is copper 1 or copper 2. You have to state them. These are the common ones that we normally meet in your BC. Meanwhile, for the rest, like the sodium, the magnesium, you do not need to state their oxidation state because they are not variable, they are fixed. Sodium will always have +1. So if you meet copper and iron, meanwhile there are some other examples, you have to state the oxidation state of those atoms before you proceed. So with these two concepts cleared out, polyatomic ions cleared out, and variable oxidation state, let's go right in. Our first example that we'll be considering is CuSO4. CuSO4. How will you name this compound? Well, the first thing we have to do, according to our explanations, you can see that we have SO4 here. Let's look at our polyatomic ions and see. You see, we have SO4 2 minus, which is sulfate. So that means this SO4 is what? Sulfate. Good. You see why I said you should just know the polyatomic ions and then you are good to go? So that is sulfate. And then we have copper. So that means basically this compound here, the systematic name is copper sulfate. Good. That is copper sulfate. In fact, you are done 90%. 90% done. But look at this. Remember, we also said that copper and iron have variable oxidation states. Copper has variable oxidation state. And if remember, I said the oxidation state of copper can be 1 or +2, +1 or +2. So here is the question you have to ask yourself. In this compound, is the oxidation state of copper +1 or it is +2? So you have to state it, because the one that sees this compound has to understand whether copper in this compound is +1 or +2 oxidation state. That is why you have to specify the oxidation state of copper. But how do we know the oxidation state of copper in this compound? To put it simple, you can see that sulfate is SO4 -2. So since we wrote this compound CuSO4, and then the 2 here has disappeared, it's nowhere in this compound. That means this copper is actually copper 2. Why? Because if this copper is copper 2, the 2 had cancelled the -2. So it is actually something like this: Cu2+ and SO4 2+, that came together to form this compound. So the 2 positive and the 2 negative have cancelled out. So what that means is this atom is actually copper 2. I think let me write that very well. So let me write there. Let me clear this side. Good. So this compound, the right name is what? Copper 2. Copper 2 sulfate. So the name is copper 2 sulfate. Good. So I hope that makes sense, and we are good to go, right? Copper 2 sulfate. For our next example, we'll be looking at FeCl3. FeCl3. Let me clear this side. FeCl3. Good. For this particular example, we do not have a polyatomic ion present, but we have ion present here. In order to name this kind of compound that do not have polyatomic ion present, all you need to know is identify the atom that is present. For the first atom is a metal. The metal is iron. So we have iron. And then we have chlorine. Chlorine. For chlorine, you change the last 2 alphabets to DE. So this compound becomes iron chloride. But remember, we said iron has variable oxidation states depending on the atom it is bonding with, and that the oxidation state of iron can be +2 or +3. So the question is, what do you think is the oxidation state of iron in this particular compound? What do you think is the oxidation state of iron in this particular compound? Obviously, it's 3, and I'll explain that in a second. So iron 3 chloride. Iron 3 chloride. Why do we say it is iron 3 chloride? Look at this. Chlorine has an atomic number of 17. So its electronic configuration is 287. So that means chlorine needs only 1 more electron to be stable. For chlorine to form iron, it borrows 1 more electron. So the ionic state of chlorine is Cl-, something you are very familiar with, which presupposes that this FeCl3 is actually a combination of Fe and Cl-. But if you look at this FeCl3, the 3 below, or the subscript 3 of chlorine, actually came from iron. So that means the oxidation state of this ion is Fe3 plus. That is the oxidation state of the ion in this compound. So the actual systematic name of FeCl3 is what? Iron 3 chloride. Let's pick our next example. Our next example is NH4 NO3. If you think you know it and you are confident in yourself, then you can actually pause the video and name it and see. So how do we name this compound? We have NH4 and NO3. So let's look at our polyatomic ions. For our polyatomic ions, we have Na4 plus, Na4 here, and this ammonium. You see? So that means the first part of this compound is ammonium. So this is ammonium. And this NO3 also looks like a polyatomic ion. NO3 minus. Good, so we have ammonium nitrate. Ammonium nitrate. We are done. No long talks. You see why I said if you master the polyatomic ions, it becomes very easy for you to name these compounds. So you have ammonium nitrate present. Good. Let's pick our next example. So your responsibility, master these polyatomic ions. Our next example is quite, it's also easy. Yeah, we have NaHCO3. What do you think is the name of this compound? Let's look at our polyatomic ions and see. You see this? That is HCO3 minus. What's the name? Hydrogen carbonate. Yes, it's HCO3. So this compound is actually formed like this, from sodium ion and then HCO3 minus. These two came together to form NaCO3. So what will be the name of this compound? You can pause the video and name it and let's see. Okay, so if you are back, the name of this compound is what? Sodium hydrogen. I guess you got it right. Sodium hydrogen what? Sodium hydrogen carbonate. Carbonate. Simple. So it is of utmost importance that you know the what? You know the polyatomic ions, their symbols and then their names. Good. Let's pick our next example. So clear this out. Good. That's satisfying. Our next example is something you are very familiar with. NaOH. I think you've guessed it already, right? There is a polyatomic ion in this compound. What is that polyatomic ion? That is OH minus. And OH minus is what? Hydroxide. So there's a hydroxide attached to sodium. So actually this compound is formed from sodium and OH minus. Sodium and OH minus. So this compound is what? Sodium and OH minus is what? Hydroxide. Sodium hydroxide. Easy peasy, right? Yes. Someone will say easy peasy. Lemon not lemon squeezy. So let's clear this side as well. Then we pick our next example. Good. Our next example that I have here is NH4OH. NH4OH. OH. You can pause the video and give this a try. What do you think is the name of this compound? What's the name of NH4OH? So NH4, let's go back to our polyatomic ion. Our polyatomic ion here is ammonium. So we have ammonium here, NH4 plus, and then we also have OH minus, which is hydroxide. So OH minus. Good. So how will you name this ammonium? So ammonium, what? Ammonium hydroxide. Finish. Ammonium hydroxide. As simple as ammonium and hydroxide combined to form ammonium hydroxide. For the next example, I'll leave it for you to write the answer in the comment section. And anyone who gets it correct, I'll give the person a shout out in our next lesson. When I say a shout out, I'll mention your name. Yes. So if you write the name of the one I'm coming to give you now, you can just write your name in the comment section, attach to your answer, and I'll mention your name in our next video. So the example we have here is, let's see which one would go with. Okay, let's go with, I have so many examples here. Okay, FES. Let's go with FES. Yeah, very simple. FES. FES. What is the name of this compound? Remember, write the name of the metal first, and then sulfur will be sulfide. And don't forget the oxidation state. So FES, what will be the name of this compound? Our next example that I'll be picking is what? CaCO3. CaCO3. So let's clear this out. So we have CaCO3. So we have a polyatomic ion here. You see CO3, where is it? CO3 2 minus carbonate. So that means this compound is formed from Ca2 plus and CO3 2 minus. Actually, if you don't understand how we got Ca2 plus, I've already recorded a lesson on formation of cations, how cations are formed. So you can watch that lesson and familiarize yourself with that concept. And hopefully, it should be easy for you to handle. So you have Ca2 plus. So CaCO3 is formed from calcium ion and this carbonate ion. So what will be the name of this compound? So this is basically a calcium carbonate. Calcium carbonate. So let's write the name calcium. This is one of the common compounds that we normally find. So we have calcium carbonate. Carbonate. So this is the last example that we will pick. But as a bonus, I'm going to show you another interesting way of writing this compound, the name of this compound. Do not kill yourself so much you find it difficult, but I'll make it easy for you. You know we have calcium here, right? So what is the systematic name of this compound if you want to write it? We can write this with calcium. Good. This is calcium. What about CO3? CO3. How do we name it? But it's simple. You see, there is 3 here, right? So this 3 is called tri. And then the 3 is a subscript of oxygen, so trioxo. So this trioxo means there are 3 oxygens here. So you have calcium trioxo, and we have C, carbonate. calcium trioxocarbonate. They have calcium trioxocarbonate IV. That's 4. Calcium trioxocarbonate 4. Have I confused you? Yes, maybe successfully. I've successfully confused you, but I brought this up so that you know that in our next lessons, we'll be looking at how to name these compounds this way. But let me give you some brief explanation. Calcium is from this. Then the tri is from the fact that there are 3 oxygens here. So you have calcium trioxo. Calcium, 3 oxygens, carbonate because of the presence of carbon. And why do you write carbonate 4? Well, remember carbonate is CO3 2 minus. Good. In your Form 3 syllabus, you might be asked to learn how to find the oxidation state of atoms, right? So how do we find the oxidation state of carbon? So the 4 here tells us the oxidation state of carbon in this compound or in this side. So we'll assume the oxidation state of carbon here is X. That is what we are trying to find. So X plus. The oxidation state of oxygen is always -2. You should know that. This -2 is different from this -2 here. This -2 here is the charge for the entire polyatomic ion. So X plus the oxidation state of oxygen is -2. But how many oxygens do we have? We have 3 of them. So 3 times the oxidation state of oxygen, which is -2. So oxidation state of carbon, which is X, plus the oxidation state of oxygen, which is 3 times -2, is equal to the oxidation state of the entire ion, which is -2. So you have X plus 3 times -2 gives us -6. It's equal to -2. Good. So X will be equal to, we bring this -6 to the other side of the equal to sign. So you have -2 plus 6. X equal -2 plus 6 gives us plus 4. So this plus 4 is the oxidation state of carbon. That is what is written as IV. This is quite lengthy, but it's an essential thing you have to learn when it comes to finding oxidation state of atoms. Actually, this is quite a lengthy lesson, so we'll end here. In our next lesson, we'll be looking at more examples of how to name compounds. We will look at how to give the systematic name of specific compounds. So if you find this lesson helpful, give it a thumbs up and leave a comment in the comment section. See you in our next lesson.